I'm gonna not touch it. So yesterday, the most important part to start, I said my very first statement over here was isolate the square term. So learning how to isolate it correctly is what we're working on. So that x squared needs to be alone. So I would subtract the 14. So that x squared is more alone. And then I would divide the 2 so that x squared is more alone. This is like multiplication right here. And then we have x squared equals 28. And now the square term is isolated. Sometimes the square term is like in parentheses. Like this is the square term here because all of everything, the expression is squared. But this time it's just x squared. Okay, now we're going to hit the square root. A square root will help us figure out what x is because it'll cancel out the little 2. The square root and the power of 2 completely cancel each other out. And we have x equals plus or minus the square root of 28. So the second thing we talked about yesterday is when you're solving by square rooting, you need a plus or minus sign. The negative, when it gets squared, turns positive. So we have to think this could be a positive or it could be a negative, which is really what creates the two sides of a parabola. The fact that this could be positive or negative. So when I put this in my calculator, if you have the TI-36, your square root button is, come on, is second x squared. Go ahead and put it in your calculator, see what your calculator does. 28 square rooted is a decimal. But your calculators are doing something different in decimal, probably. Did anybody's calculators pop out 2 square root 7? Right? Okay, that's a good thing. The reason your calculator is not giving you a decimal is because mathematicians don't want this written as a decimal. They don't want to compromise this square root and round it. They want it in perfect exact form. So we practice it a lot in math class. So this is called simplest radical form. So we're going to focus for a little while. I mean, when we go to a word problem, we'll probably look at decimals so we can conceptualize it. But for now, we want to talk about no decimals. We want to utilize simplest radical form. You have to prove that you understand what the calculator is doing. So how did your calculator go from 28 to 2 square root 7? You have to show that word. What they're doing is looking for perfect square factors. So here's my list of numbers that I think most of you all have memorized. All of the perfect squares. 1 squared and 2 squared and 3 squared and 4 squared and 5 squared and 6 squared and 7 squared. 28 is not on the list. But what I'm going to do is I'm going to look at the list for a number that 28 will divide by. Does 28 divide by 16? It doesn't. Does 28 divide by 9? No, it doesn't. Does 28 divide by 4? Yes, it does. So I'm going to acknowledge that there's a perfect square factor here. And I'm going to rewrite 28 as the square root of 4 times the square root of 7. And that's going to make this a more simple radical. The square root of 4, I'm going to go ahead and do. The square root of 4 is 2. This is what your calculator did to pop out 2 square root of 7. So your best answer for full credit is x is plus or minus 2 times the square root of 7. Not a decimal, but what we call simplest radical form. Does anybody remember doing that ever in geometry or algebra? Oh, good. First period, 2 people, I guess. This class like 6 days, so a little bit more. Maybe as we do it, you might remember it, you might not. No big deal. So anyway, your calculator will do it for you, but you need to show what your calculator did. In college algebra, they won't let you use calculators for part of this. In ACE Math, you're allowed to use your calculator for everything. So let's go to number 2. Number 2 I picked to go through with you because of the fraction. Coming through again. Hope I can fit. I wanted to go back to groups, but my next class says it's over quiz today. We should be back in groups any day now. Okay, number 2. 3/4. Yep. X plus 1 squared equals 10. I see vertex form here. I see an A value. I see an H value. If I subtract the 10, it would be a K value. So this equation looks like something that I could graph almost. Okay, so this whole thing is squared. So in order to isolate this, I want to get rid of this fraction in one move. So I'm going to multiply by the reciprocal. So you flip that fraction. 4 thirds times 3 over 4 is 12 over 12. So that's 1. So it cancels it out. So boom, it's gone. And then I have x plus 1 squared equals, this is like 10 times 4 over 1 times 3. 40 over 3. Good. And then now our square term's isolated, so we will square root both sides. When you have the parentheses, the whole expression squared, and you square root it, you can then drop the parentheses. So the square root and the 2 are gone. We no longer need the parentheses. I have x plus 1 is plus or minus. As soon as I write the radical, I write the plus or minus sign. Plus or minus the square root of 40 over 3. And then one last move to get x alone, minus the 1. But I can't minus the 1 from this because it's in a square root bar, so it takes a minute to get used to, but you put that number in front of the plus or minus. It's a -1, and it's a positive or negative square root of 40 over 3. And since we don't want decimals, we're not going to divide that. We're not going to square root it. We're just going to leave it just like that. A mix? What is it? 11, 12, 13, 13 and 1/3. I wouldn't mark it wrong. On standardized tests, though, they don't let you do that. Like if it's a type in, they want you to type in like that. It would read it as 131 over 30. So, but this makes more sense. Like, oh, 13 and 1/3, I get it. 40 divided by 3. Anyway, I'll leave it like there. You're welcome to do that too. All right, who's got a question about this one? So what you're getting used to is how strange the answers look. And you might feel like, why don't I just make this a decimal and make this a decimal, 13.3, square root it, add -1. But we're really trying to preserve the whole number, so we're going to keep it in the radical form. Any questions? All right, go ahead and think of a number 3. Yeah. Okay, I'm coming back through this. Actually, I decided I just want to move that. I wish there was a different outlet for it. There isn't. Because I plugged it in on my. What do these answers represent? Anybody have an answer for 3 vocabulary word that maybe we talked about 2 days ago? Yeah. X-intercepts, and what were you gonna say? Yep. So these answers are x-intercepts, and the word we talked about the other day was roots. So roots and x-intercepts are the same thing. Okay. So the reason, so chapter 1, chapter 2, we graphed a lot of regular numbers. It was integers. It was like positive 3, negative 3, negative 4. What is this? Right? What is this? What is this on a graph? If you want to know what it is, when your calculator cuts out 2 square root 7, the button above the enter puts it in decimal form. I don't want decimal form, but we're going to talk about it for a minute. This is the equivalent of 5.29. Okay, and the truth is, when it comes to parabolas in the real world, when it comes to machinery, where parabolas are needed, or architecture, or the gravity of any objects, most of the time it's working with decimals. We had a teacher here last year who was an engineer and he was teaching math, and he was like, why do you guys do all these problems with like regular numbers? Like everything in real life ends up being complicated. Like everything in real life is a decimal. So all of our problems that land exactly on perfect points on a graph, he was kind of like, you know what, that's not really the kind of numbers we work with. So when you picture this weird number, even though we keep it in perfect radical form, it's okay to understand the decimal form. This is just saying 5.29 exactly and negative 5.29 exactly, which is probably more accurate for a lot of the quadratics that are used in real life. It's not going to land perfectly on 5. Not every, arch is going to land perfectly 5 feet away. It's going to be some decimal. So these weird answers are actually more likely to use in a real engineering class. So it's good to practice that. All right, now let's look at the problems from yesterday. You can ask about the more difficult ones, 15, 16, 17, 18, or you can ask about 11, 12, 13, or 14. I can zoom in on any of these. Yeah, maybe let's just jump right to number 18. I did utilize the reciprocal in 18. Oh, shit. I'm going to disconnect and reconnect, and maybe it'll go better. Okay, here's 18. So, collect your x squareds together, subtract 1/5, you end up with 2/5. Then, I use the reciprocal like I did over there. I flip the 2/5 to 5/2 on both sides. And that made 10/2, which is 5. 5 is x squared. X squared is 5, square root, and then you don't actually square root 5. You just leave the radical there, plus or minus square root of 5. So this is plus and minus the square root of 5. Leave it like that. Which one should I zoom in on next? Yeah. 17 is a special solution. So on 17, when you collect the r squareds together, you subtract. The negative 10 is still there. When you go to square root it, you actually can't square root a negative. Well, you can, and we will. We're going to call that imaginary, but for now, we're just going to say this is no real solution. So as soon as you have the chance to square root, because your variable is isolated, but it happens to be equal to a negative, for now, we're just going to call that no real solution, because nothing squared comes out negative. So that has a special answer, that one. Okay, let's go ahead to 15 and 16. See what those look like. I specifically picked the Bellward questions to help you understand kind of the endings of these. Alrighty, who's got a question now? 11 through 18. Well, good question. If you can square root, like on this one, 49 actually does square root. I was able to make it a regular number without using a decimal. Now I can do that I can add the 4, and I can actually do 4 plus 7 and 4 minus 7 and get two regular numbers out. Now, had this been a 40, for instance, 40 doesn't square root, it would be 4 plus or minus the square root of 40. So if the square root is not one of these numbers, you're going to keep the radical and keep a plus or minus. So it's all about whether or not you can square root it and then add at the end. Like square roots, this square roots, this square roots, this square roots. So these all have regular answers. And then right here, all of a sudden, oh no, 2 makes a decimal. So the plus or minus remains. Weird fraction makes a decimal, plus or minus remains. What did we get in the points that we only put 1? 1 answer? Yeah, it's half. Half credit. Thanks for bringing that up. Yeah, if you forget the plus and minus sign, you're looking at, half the problem, so you get half credit. You need full understanding, a full comprehension of 2 answers for quadratics to get full credit. Actually, there are some with only 1 answer. You ready to move on? Yeah, I'm going to do 3 more problems and then I'll talk about that. Let's see 3 more. Any more questions about these? Alright, I have 3 more problems for you to try, just to see, okay, do I understand this? So, You don't have to do all three. I think you should. But if that's not where you're at today, pick one and see if you can do it. Pick two and see if you can do it. Let's do three from scratch. I did three yesterday with you. We just did bell work. You tried your assignment. Let's try these now. These are extra problems before we move on. Alright, three problems for you to give this a go, and then we're going to move on to the topic. So, it's not really new. It's a different way of doing the same thing. You talk to the people next to you. Hey, what'd you get? Where? What do you mean? From Bellward? I think I erased it. You did it. Alright, number one here. Maybe try number 2, maybe try number 3, maybe did all of them. First thing I gotta do here is add 6. And I would get 2x squared equals negative 6. Divide by 2. And I would get x squared is negative 3. Take the square root. And then right then and there, an alert goes off in my mind. Alert. Don't do it. No real solution. Alright, so that one's a trick. It's right up there thinking you're going through everything just fine. And somehow, right in the middle there, your brain has to think, wait a minute, I'm not okay with this. I'm square rooting a negative. No real solution. So you stop there, don't go any further. No real solution is the answer. Yes. Nice. You don't do positive, negative until you've isolated. So before you do positive and negative, you move, like you're setting up the problem. You take the 6 to the other side, you divide by 2. Now the problem is ready to begin. Now that you've isolated. Here's where you do positive and negative, but you don't do positive and negative until the radical works. This radical doesn't work. So technically I could have written like this, a plus or minus outside here, but it's still no real solution. Okay, so there's nothing in front or behind the squared term, so I'll go right to the square root bar. The square root bar is so cool. Cancels out the 2. I no longer need parentheses. X minus 5 equals plus or minus the square root of 128. I'm curious about this number 128. Sophie, did you try to square root 128 in your calculator? What did it give you? 8 square root 2. What? How did it do it? It's not a decimal. It shows up as 8 square root 2. So there must be something that 128 divides by that will result in an 8. So I'm going to look at these numbers. Which one of these square roots to be 8? 64. So I'm going to go, wait, does 128 divide by 64? Oh, that's how the calculator did it. The calculator rewrote 128 as 64 times 2. It's a very smart calculator. You have to understand that. So technically, I should test you without a calculator on this very one skill. You're supposed to show you can do that. So now I can square root this, and it's 8 square root 2. My problem is now x minus 5 is plus or minus 8 square root 2. It's not done yet. I got one more thing to do. And a plus 5 over. The plus 5 ends up right in front of the plus or minus sign. My answer is a positive 5 plus 8 square root 2 or minus 8 square root 2. I can't really do 5 plus 8 because that's not technically an 8. It's 8 times the square root of 2, which is like 8 times 1.4 or something. So it's not an 8 there at all. So when I see 128, I have to think, does it divide by any of these numbers to put it in simplest form? And it turns out 128 divides by 64. And that's called math type on the calculator. For to get it to pop out like that. So let me show you a different example real quick, Gerard. Let's say I had to square root 72. Does 72 divide by 49? No, it doesn't. Does 72 divide by 36? It does. 72 is 36 times 2. So I would rewrite it. And 72 is the same as 6 square root 2. Simplest radical form. We do that a lot in like the next chapter. There's a whole chapter on radicals. This is just a little side note here. All right, next one. Take away the 14. Subtraction property of equality. Multiply by the reciprocal. Thank you, reciprocal. You're actually saving me a lot of work. You work so well, reciprocal. Canceling fractions, well done. That's 18 over 2. X squared equals 9. Hit the square root. X is plus or minus 3. So, let's see your opinion. Hold up fingers. 1, if you think number 1's the hardest, most difficult question. 2, if you think that's the most difficult question. 3, if you think number 3 is the most difficult question. Ready to go? 2s and 3s across the board. Good. I agree. I think 2 is the most difficult. 3 has a fraction, which is difficult. But what I really want to alert you to is on a test, you'll forget this. And it's always kind of sad. You'll forget, oh, I can't square root a negative, no real solution. Even on like the SAT, they'll pull something like this. So make sure that you put an alert and highlight it and make it a big deal for yourself that when you square root a negative, it's no real solution. So we don't forget the easier one. Nobody put number 1 up, which I think is accurate. Yeah. Oh, nice. Everybody turn to 184. All right, today we're gonna so on Tuesday, Monday, Tuesday, we said there's 3 ways to solve by graphing. We did it. We found our solve by square rooting. We just did it. This was the third one discussed. Solve by factoring. It's right here on page 184. What is happening right here? I'm gonna make a big green arrow, and I'm gonna ask you, what's the book showing you? Here's the problem. It says solve. What did the book do from this step to this step? It just says put in standard form. Right in standard form. What makes this more standard than this step? The A, the B, the C. You guys, the problem has to be set equal to 0. Make yourself a little note. So right off the bat, the book doesn't say, oh, it's standard form because it equals 0. They're saying, man, this is standard form. So they subtracted the 45 to make it equal 0. Then it says factor. Your book is assuming you know how to factor. Factoring is just a number riddle. To factor this, you look for numbers that will multiply to 45 and add to 4. Because this is writing the expression, it's the same expression written 2 different ways. And you know how when you FOIL, you do x times x, x squared, x times 5, 5x, negative 9 times x, and then finally negative 9 times 5 would be negative 45. When you factor, you try to figure that pattern out to rewrite a problem. So when I look at A being 1, B being negative 4, and C being negative 5, to factor, I like to use a little table. I find numbers that will multiply to negative 45 and will add to whatever's in the middle, negative 4. You want numbers that will multiply to the C value and add to the B value. So I'm going to stop and I'm going to fill out my table and I'm going to think about everything that multiplies to negative 45. There's 1 times negative 45. 2. Does 45 divide by 2? I'm going to check my calculator. No. Does 45 divide by 3? Actually does. We could do 3 times negative 15. Does 45 divide by 4? No. Does 45 divide by 5? It's 5 times negative 9. I think that's it. That's everything that 45 divides by. So I list all the factors of the C value, and then I try to add them together to see which ones will combine to be the B value. This last group jumps out at me. Yeah. 5 minus 9, that's negative 4. So I'm gonna just check it. 5 minus 9 is negative 4. So because these two factors combine to create that middle number, I know these are the numbers that I use to write in factor form. Sorry. So to write it in factor form, you pick the numbers that work, you use 2 sets of parentheses, you put the x in, and then you put the numbers in that you picked. It was a positive 5 and a negative 9. Now look, the book wrote the minus 9 and then the positive 5. It doesn't matter what order you do it. This is correct. This is correct. It all works out to be the same thing. One last step is to solve these little guys. So I'm going to do x plus 5 equals 0, x minus 9 equals 0. I call these little baby equations. And I get x equals negative 5. And I get x equals 9. And those are x-intercepts. So I think that's easier than graphing to find x-intercepts, and I definitely think that's easier than whatever's happening here in number 2. Of course, these are integers, and number 2 is a more complicated number. But it's all the same concept, whether you're graphing for x-intercepts, square rooting for x-intercepts, or factoring for x-intercepts. It's all the same thing. The directions are going to say find a 0. Zeros are x-intercepts. It's just another root, another word for root. So today you're practicing this. It's page 191, number 39 to 44. So you have 6 chances to try to figure it out. I'll go over them tomorrow. So you do your best. Find the numbers, and I'll go over them tomorrow.